So guys, now let us write a very simple example which demonstrates the use of semaphores. So in this example, we will going to create 5 threads, and out of these 5 threads using semaphore, we need to restrict only 2 threads to execute inside critical section, right? The rest of the 3 threads must wait outside the critical section and must enter into the critical section only and only when the executing thread inside the critical section actually leaves the critical section, right? So in this simple example, we will going to fake the critical section code by simply printing some message by the executing thread inside the critical section. This is the source file which you can refer, and it is this source file which we will going to discuss, right? So the problem statement is very simple. We will have 5 threads and we need to allow only 2 threads to execute in the critical section at any point of time. So guys, on the screen you can see that I'm inside the directory multithreading / semaphore, and this is the file which we will going to implement, right? So this is a very simple example which demonstrates the use of semaphores. So I have written some raw code in this example and we will going to enhance this code. So you can see that we have a main function, and because we need to create 5 threads, therefore I have taken 5 thread handles, right? And using these 5 thread handles, I will going to create or launch 5 threads, right? So I'm using a common API thread_create in order to create 5 threads. And the threads are tied to the thread function, which is very simple function, and this function simply make the thread to execute in a for loop for 5 seconds, right? Here you can see that I'm using sleep1. Also, the argument that is passed to this thread function is nothing but it is just a string to identify which thread it is executing, right? Because all the 5 threads will going to be execute inside this thread function, so we can make use of this thread name in order to identify that exactly which thread is actually executing inside this for loop. So if you compile this program and run, you would see the output something like this. That is, all the 5 threads would be ending up executing inside the for loop. In this example, we have considered this for loop as a critical section code, right? So it is just a simulation of critical section. It is really not a critical section because we really not have any shared data structures between the threads. But our focus is on how to make use of semaphores to limit the number of threads executing inside the critical section. So actually what critical section code it is not important. The important is how to limit the number of threads to execute inside the critical section. So as of now, we have no semaphores in this program. Therefore, all the 5 threads would end up executing this for loop, right? So now let us make use of the semaphores and see how we can allow only 2 threads at a time to enter inside this critical section. So very first thing that I would do is to hash include the header file semaphore.h. Now this example also make us familiar with the semaphore APIs. So after including this semaphore.h header file, I can now define the semaphore object, right? So semaphore object can be created by using this data type sem_t. This is the Posix data structures which is provided to us in order to declare semaphore variables, right? So we have taken one semaphore sem, or let us call it as sem or semaphore. Now because we need to allow only 2 threads to enter inside the critical section at the same time, therefore permit count value has been defined to 2, right? Now in the main function, the very first thing I would do is to initialize the semaphore. In order to initialize the semaphore, we have an API sem_init, and it accepts 3 arguments. The first argument is a pointer to the semaphore which you are initializing. The second argument you can always pass to 0. We will come back to this second argument later. And the third argument is the initial value with which you want to initialize the semaphore. Here we are initializing the semaphore with the value 2, right? So it would mean that our semaphore would allow two threads to enter the critical section, right? And when all the threads have finished executing the critical section and join the main thread, then you can actually destroy the semaphore before you exit the program, right? So for that you can use API sem_destroy. So now the initialization and destruction of the semaphore is complete. Now let us focus in this function, that is thread function callback. We need to protect this critical section in a way such that only two threads execute concurrently inside this critical section, right? So to begin with, at the beginning of the critical section, that is at the entry point of the critical section, we need to make use of semaphore such that semaphore allows only two threads to enter inside this critical section, right? So for that, we are given an API sem_wait, right? And we need to pass the pointer to the semaphore to this API. So as soon as the thread executes this API, the value of the semaphore is decremented by 1, right? And if the thread is allowed to bypass this semWait API, it means the thread has entered into the critical section. So before invoking this call semWait, we can again print some message that a thread and printing the thread name is entering into the critical section. And after that, the thread invokes an API semWait, and depending on the semaphore counter value, the thread will be either blocked or it will pass through beyond this call, right? If the thread has passed beyond this call, it means that the thread has entered into the critical section, right? So our thread will execute inside this critical section for 5 seconds. And when our thread has done its execution of the critical section, then it's a time for our thread to print the message to tell the user that it is exiting the critical section. And before exiting the critical section, our thread should increment the value of semaphore counter and send signal to any thread who could be waiting on this semWait call, right? So for that, our thread make use of an API semPost. semPost is analogous to pthread condition signal, right? And once the thread has completely come out of the critical section, we can simply print a final message that the thread has exited from the critical section successfully, right? And this completes the implementation of our problem statement. So you can see that using semaphore, how easily we can control the number of threads to execute inside the critical section concurrently, right? All you need to do is to sandwich the critical section between semWait and semPost APIs, right? The semWait API will block the thread if the value of the semaphore after reducing becomes negative. Otherwise, it will simply reduce the value of semaphore and allow the thread to bypass the semWait call, right? And the semPost API does the exactly opposite thing. It increments the value of the semaphore and send the signal to any thread who could potentially wait or blocked at the semWait call, right? So now if you compile and run this program, you would only see that at any point of time, only two threads would be executing in the critical section, right? So I leave it to you because this example is very simplistic example, and from these printf statements you can very well make out that only two threads at any point of time must be executing in the critical section, while the other threads has either already exit out from the critical section or they must be waiting at the entry point in the critical section, right?